Hi, I'm Ms. Cho, and in this video, we'll multiply rational expressions and find their domains. When we talk about rational expressions, we mean that we have one polynomial divided by another, and we can multiply them by other rational expressions, like two fractions. So it's the same thing that you would do in multiplying two numeric fractions. If you had 3 times 4 times 8 times 9, you would just multiply across the top, multiply across the bottom. So you have 3 times 8 in your numerator and 4 times 9 in your denominator. From there, you would cancel any common factors. I can actually rewrite 3 times 8 as 3 times 4 times 2, and I can rewrite the 9 as 3 times 3. If I do that, I see that I have a 3 that is in the numerator and the denominator, and then I have a 4 that is both in the numerator and the denominator, which means that what I have left is 2/3, which is a fraction in simplest form. Alternatively, at the first step, I could have said 3 times 8 is 24, and 4 times 9 is 36. And so I could have rewritten this as 12 times 2 times 12 times 3, and then divide out the 12 and get 2/3. Either way, I end up with the same simplified form. Let's take a look at an example. In our first example, we're asked to find the product and domain of 5y minus 20 over 3y plus 15 times 7y plus 35 over 10y plus 40. To do this, we're going to follow 3 steps. First, we factor our expressions, the numerators and the denominators. Then we find the zeros of all the denominators. These are the values that will make our expressions undefined. Third, we'll multiply across the numerator and the denominator, and we'll cancel any common factors that appear in both. The numerator of our first expression has a GCF of 5, so I can factor out the 5, and I'm left with y minus 4. In my denominator, my GCF is 3, and I am left with y plus 5. In my second expression, I notice that my greatest common factor is 7, and I have y plus 5, and my denominator has a GCF of 10, and I have y plus 4. Now that I've factored, I want to find the zeros of all my denominators. So I'm going to set y plus 5 is equal to 0, and that gives me y is equal to negative 5, and y plus 4 equals 0, which gives me y is equal to negative 4. These are the values that if I plug in, will make my denominator 0 and my expressions undefined. So these I will have to exclude from our domain. In my third step, I multiply across and I cancel any common factors that appear in both the numerator and the denominator. I notice that I have a common factor of y plus 5 in the numerator and the denominator, so those cancel. And I also notice that 5 and 10 share a common factor, so 5 goes into 5 one time, 5 goes into 10 two times, and so what I'm left with is 1 times y minus 4 times 7 divided by 3 times 2 times y plus 4. And if I want to simplify this further, I'm just going to multiply all my numbers together, and I get 7 times y minus 4 over 6 times y plus 4. And my domain then is all y's except for the values I found in step 2, so y equals negative 5 and negative 4. Even though my new denominator only seems to have a negative 4 be problematic, because the negative 5 made my original denominator 0, I cannot include it. Let's try a second example. In our second example, we're asked to find the product and domain of x squared plus 6x plus 8 divided by 8x squared plus 4x plus 3 times x plus 3 over x plus 2. Even though we have more terms now, we're still going to follow the same 3 steps. I'm going to factor each expression, I find the zeros of my denominators, and I multiply across and cancel common factors. So my first expression, I am looking for 2 numbers that multiply to 8 and add to 6. So I think that's going to be 4 and 2. So my factors are going to be x plus 2 and x plus 4. My denominator is going to be 2 numbers that multiply to 3 and add to 4. So that's going to be x plus 1 and x plus 3. My second expression is already factored, so I'm just going to rewrite it as is, except I'm going to add parentheses to remind myself that this is one whole unit, and I can't take pieces of it apart. I have students that will try to do, x divided by x, And then that means my second expression is 3 over 2. This is not true. You cannot do that. So let's undo that and find the zeros of our denominators. So I have 3 factors in my denominator. I'm going to set them all equal to 0. X plus 1 equals 0 gives me x is equal to negative 1. X plus 3 equals 0 gives me an x equals negative 3. X plus 2 equals 0 gives me an x of negative 2. From here, I can multiply across and cancel any common factors. I notice that I have an x plus 3 in the numerator and an x plus 3 in the denominator. I have an x plus 2 in the numerator and an x plus 2 in the denominator. That means I am left with x plus 4 divided by x plus 1, and my domain is all x except for the values that we found in this step, x equals negative 1, negative 3, and negative 2. Let's summarize. When we multiply rational expressions, we factor the numerators and our denominators. We find the zeros of their denominators, and then we multiply across the top and the bottom and cancel any common factors that appear in both. The domain excludes all undefined values that make your original denominators equal to 0.